In the name of God. Hello, students. My name is Masoud. I'm physics teacher. We are in Ferho's website at your service to explain the physics curriculum, grade 10. Actually, you can download our application. We have an application uh, by this name, Ferho's application, to get our videos. I hope you enjoyed this lecture. So far, we talked about. Actually, we finished the chapter one. We finished chapter one, and we solved some questions from chapter review. But I forgot to solve one question for you about the dimensional analysis uh, and order of magnitude. Let's move on to this. Let's go back to this question, and after that, we will continue our, let's say, questions of chapter review. Let me go back to this question. I forgot to solve this problem for you. It's very important. Let me, let's say, solve it for you. It's about dimensional analysis and order of magnitude. You know what dimensional analysis is, and you know what order of magnitude is, yeah? On order of magnitude means nearest power of 10 to the numerical value of the quantity, right? Yeah, this is the question. I forgot to solve this problem for you. Question number 10, using dimensional analysis and order of magnitude to find an equation for time taken by a car to travel a distance 725 kilometers with the speed of 88 kilometers per hour, right? What's the given actually, or what's unknown? They are given actually. We have distance and velocity of the car. What do we look for? We look for it says equation for time interval. We want to find the time interval. Let me. So we look for this equation, right? It's just an equation for what? For time interval. We have two things. We have speed, velocity, let's say velocity, and we have distance d, right? Delta t is equal to what? Delta t is equal to delta x over v. So this is your equation. Maybe you don't get it in one trial. You try once and twice to get this rule actually. Delta t is equal to delta x over v. Why do we use this equation? If you, let's say, try multiplication, if you say delta t is equal to delta x times v, you don't get the, let's say, uh, dimensions are not consistent. The left side of the equation does not coincide with the right side. That's why, let's say, this is the true rule. Delta t is equal to delta x over v, right? So what's the distance traveled by the car? 725 divided by 88. What's 88? Velocity of the car. Whenever you divide it, you get this number, 8.2 hours, right? This is exact answer, but it's not our answer actually. It says using dimensional analysis and order of magnitude. Actually, we used dimensional analysis to find this equation, but right now we want to, let's say, convert the exact number into the what? Into the order of magnitude, into the power of tens. So 725, which power is closer to this number? Actually, 10 to the power 3 divided by 88. Which power, let's say, is closer to this number? 88, actually, 10 to the power 2. Whenever you divide them together, write one common base, 10, and subtract the smaller exponent from the larger exponent, and the answer will be 10 hours, which is very close to the exact answer actually. This is actually, we combine, in this question, we combine two things. We combine dimensional analysis for finding the rule and our order of magnitude to what? To find the answer, right? So this is the question that I forgot to solve it for you in previous lectures. Let's move on to the chapter review. So we solved 10 questions in previous lectures. Right. So right now I wanna explain question number 11. It's about conversions, right? Question number 11. Express each of the following as indicated. To, let's say, decimeter, this is deci. To decimeter, we want to convert it to what? Excuse me. To decimeter, we want to convert it to the what? To the centimeter, right? Decimeter to centimeter. This question includes, let's say, prefixes in both numbers. That's why it takes more than one step. The first step is to write the value of deci. How much is the value of deci? 10 to the power negative 1. So it will be 10 times 10 to the power negative 1 meters. We want to convert it to centimeter. Are we done? No. So we have one more step. We will continue. Meter converted to centimeter. From larger unit to the smaller unit. So you have to use positive powers. But where does, let's say, the power come from? Where shall I take the power actually? From centi. Centi means 10 to the power negative 2, right? Take this power and remove the negative sign because you convert meter to centimeter, larger to the smaller one. That's why you have to remove this negative sign and it will be 10 to the power 2, right? So right now multiply these numbers to get the final answer. It will be 2 times 10 to the power 1 centimeter, or we can say, simply we can say 20 centimeters. Let's move on to another question. The same question, B. 2 hours and 10 minutes, we want to convert it to the second. 2 hours and 10 minutes. So each hour contains 60 minutes, right? 1 hour is equivalent to 60 minutes. So 2 hours means 2 hours and 10 minutes, 2 hours plus 10 minutes. Instead of hour, I can write its value, right? Like this. Instead of hour, I write, let's say the value of the hour actually in minutes, right? 2 times 60 plus 10 minutes. So I can say the whole operation is minutes, yeah? Is in minutes. Actually, it will be, this is 120 plus 10. It will be 130 minutes, right? We want to convert it to centimeter. Actually, the calculation has not done yet. We have one more unit, one more step. So how many seconds are there in 1 minute? 60, right? So 130 multiplied by 60. So the answer will be 7,800 seconds or 7,800 seconds, right? C, 16 gram expressed in microgram. We want to convert gram into what? Into the microgram. Gram into the micro. Is it from large to small or from small to large? Yeah, think about it. Actually, it's from large to small. Gram is much more greater than micro, actually. So where shall I, let's say, take the power? From micro, but we have to remove the negative sign because micro means 10 to the power negative 6. This one means 10 to the power negative 6. Remove the negative sign. It will be 10 to the power 6, right? This is the answer, right? And you can write it. If you leave the answer like this, it's right. It has no problem. But if you put a decimal point here, you add the decimal point, you can say 1.6 times 10 to the power 7 what? Microgram. You can, let's say, simplify it like this. This is the last answer. And if you leave it, no problem, it's right. Let's move on to another one. Other question. D, 0.75 kilometers expressed in centimeter. Kilometers to centimeters, right? So 0.75 is a fixed number. You know this. Kilo means 10 to the power 3, right? Just write the value of kilo, 10 to the power 3. And this is the first step, right? Meter to centimeter. Right now, we want to convert meter to centimeter from larger to the smaller. So you have to use positive power. Take the power from centi. Centi means 10 to the power negative 2, right? 10 to the power negative 2. Remove the negative sign and write it here. And multiply the, let's say, terms together. We have three figures here. Multiply them together to find the answer. It will be 0.75 times 10 to the power 5 centimeter. And if you leave it such this, actually, it's right. It's no problem. But for, let's say, simplifying the result, you can write it as a scientific notation, put a decimal point, actually between 7 and 5. So right now we have two, let's say, decimal places. By putting the point between 7 and 5 means you reduce the decimal place into the what? You reduce it. You reduce it, let's say, you reduce one decimal point. That's why you have to reduce the exponent. It will be 7.5 times 10 to the power 4 centimeter. Keep in mind that reducing, let's say, decimal place equivalent to reduce the power, or vice versa. Increasing the decimal point is equivalent to increasing the exponent. They are actually directly proportional to one another, right? Let's move on to another question. 0.675 milligram expressed in gram. We want to convert it to gram, right? Right now, let's say put it here. This number, milligram to gram, right? Milligram to gram. So right now, milli means you convert from small to large, milli to gram. That's why you have to use, let's say, negative. Just write the value of milli and that's it. So 0.675 multiplied by 10 to the power negative 3 grams. This is the answer. If you want to, let's say, round it, or if you want to, let's say, write it in a, let's say, nicer way, you have to put a decimal point between 6 and 7. It will be. So what did you do by this, let's say, calculation? What did you do actually? You reduce the decimal point, right? That's why you have to reduce the power as well. It will be negative 3 minus 1. The answer will be 10 to the power negative 4. Let's move on to another one. F, 462 micrometer. We want to convert it to centimeter. Micrometer to centimeter. This is micrometer to centimeter. So in both figures, we have, let's say, prefixes. That's why it takes more than one step. The first step, without thinking, just write the value of micro, which is 10 to the power negative 6. So 462 times 10 to the power negative 6 meters. So micro, let's say we don't have micro anymore. We have only meters, right? This is the last step actually. We want to convert meter to centimeter. Is it from large unit to the smaller one, or from smaller one to the large one? Think about it. Actually, a meter is larger than centimeter. That's why you have to, let's say, write the positive power. But let's say, where does the power come from? You have to take it from the centi. Centi means 10 to the power negative 2. Just remove this sign. Remove the negative sign. So this is the last answer. 462 multiplied by 10 to the power negative 4. If you leave it, I told you, like this, no problem, it's right. But mathematically, it's not nice mathematically. You you have to put a decimal point here, right, between 4 and 7. What did you do? Think about it. So you added decimal, let's say, places. That's why, how many decimal places did you add? Actually 2, right? So you have to, let's say, add 2 to the negative 4. And the answer will be 4.62 times 10 to the power negative 2 centimeters, right? Let's move on to another one. Another question. It's a little bit different, right? I have I have 2 notes about this question exactly. It's very important. So be with me, pay attention to explain this one. It's different from the other questions. Let's say I haven't solved any question yet, right? Right now, I want to solve this problem. 35 kilometers per hour expressed in meters per second. So we want to convert kilometer per hour, right, to the kilometer per hour to what? To the meter per second. Kilometer. Actually, it's right if you say, teacher, I convert each unit separately. For example, a kilometer, you can convert it to meter, no problem. Just write the value of kilo in numerator. In denominator, you have to write the value of, let's say, hour. How many seconds are there in 1 hour? Actually, 3,600 seconds. You can write it like such this, but I simplified it for you. I just give you the fraction, the fixed fraction. I want you to memorize it for, let's say, saving time, and for, let's say, especially because you need time in the exam. You have to solve the problem, let's say, in a very short way. That's why let's say I simplify to a fraction. I want you to memorize this fraction, 5/18, from which unit to which one? From kilometers per hour to meter per second. You have to use this one, this number, this fraction. Keep in mind that this is the fixed ratio, 5/18 for conversion from kilometers per hour to meter per second. So what's our original, let's say, number? 36. So I'll bring it down here right now. I say 36 multiplied by 5/18. Is there any, let's say, simplicity or simplification, excuse me? You can simplify them together. 18 divided by itself becomes 1. 36 divided by 18 becomes 2. 2 times 5 becomes 10. And actually, we have 10 meters per second, right? It's very easy. If you memorize the fraction, memorize the ratio, let's say it takes only 1 step. Let's move on to another one, but we don't have any question about in our textbook till now. Actually, we have it in next questions, but till now, let's say we didn't encounter, let's say, the opposite case. I mean, meter per second to kilometers per hour. But I wrote a note for you. I want you to pay attention to it. To conversion, let's say, from meter per second to kilometers, to convert meter per second to kilometers per hour, use this fraction, right? Use this fraction. It's opposite, completely opposite to the, let's say, previous case. So I brought a question for you. It's not in our textbook. It's my question for better understanding. So 15 meter per second, we want to convert it to kilometers per hour, right? Let me solve it for you. I want you to be with me to solve this problem together, right? We want to solve it right now. Meter per second to what? 2 kilometers per hour. What's the ratio? Actually, the ratio is 18/5. You have to write 15 multiplied by 18/5. 5 divided by 5 becomes 1. 15 divided by 5 becomes 3. 3 times 18 becomes 54 kilometers per hour. It's very easy. It takes only one step. Actually, if you memorize the fraction, right? Let's move on to other question. Question number 12. Use the SI prefixes to convert these hypothetical units of measure into the appropriate quantities. Actually, we have a question here. It says use the SI prefix. So we have an expression. Instead of this expression, let's say we shorten the expression, right? Instead of expression, we use an appropriate SI prefix. 10 rations. 10 means deca, yeah? So it will be 1 deca ration. 10 means 1 deca, yeah? So instead of 10, I write, look here, instead of 10, I write 1 deca. So instead, I write 1 deca ration. Let's move on to B. 2,000 mockingbirds. 1,000 means kilo, yeah? 2,000 means 2 kilo. 2 kilo mockingbirds. So instead of 1,000, I write kilo. And by the way, you have to keep the constant number. Let's say you have to keep the fixed number constant, right? Without any, let's say, changing. 2 remains as it is. Just convert for example, 1,000 to kilo. And this is our goal, actually. See, 10 to the power negative 6 phones. 10 to the power negative 6, think about it. Which power, let's say, is equivalent to 10 to the power negative 6? Or which prefix? Which prefix is equivalent to 10 to the power negative 6? Actually, micro, yeah? So it will be 1 micro. This one becomes micro. Micro, and write the rest, right? It will be 1 microphone. D, 10 to the power negative 9 goats. 10 to the power negative 9 means, so which prefix coincides, let's say, with 10 to the power negative 9? Which prefix is equivalent to this power, actually? Nano, yeah? So it will be 1 nano goat. Instead of 10 to the power 9, I write, let's say, nano. And the last one, E, 10 to the power 18 miners, right? But here we have to break down the number, break down the power. 10 to the power 18, let me write it here. You can, let's say, break it down into two, let's say, powers. It will be 10 to the power 12 multiply by 10 to the power 6, right? So we did nothing, we just broke it down. Here, 10 to the power 12 means tera, yeah? Tera. So I can say 10 to the power 6 tera. 10 to the power 6 tera, right? Let's move on to another question. Another question, question number 13. 13, use the fact that the speed of light in a vacuum, this is the speed of light in a vacuum, actually. This is the speed of light, 3 times 10 to the power 8 meters per second, to determine how many kilometers a pulse from a laser beam travels in exactly one hour, right? So what do we look for? It says to calculate or to determine how many kilometers a pulse from a laser beam travel in exactly one. It says how many kilometers. So we look for what? We look for distance. How many kilometers in, let's say, in 1 hour? How many kilometers in 1 hour? So we look for distance in kilometers. Yeah, the unit should be in kilometers, should be measured in kilometers. Right now, let me explain for you. So we look for distance, right? And by the way, this is dimensional analysis. Firstly, you have to write the equation. You have to write the convenient equation. Convenient. Which equation is convenient in this situation? maybe you say, maybe you didn't get the, well, let's say, rule in a one trial. Question says find the distance in kilometers. Let me explain this one. Velocity of light, actually, speed of light is 3 times 10 to the power 8 meter per second. We want to convert it to kilometers per hour. If you know the conversion, so 90% of solution is taken place. Believe me. So meter per second we want to convert it to kilometers per hour, right? Meter per second to kilometer per hour. So which fraction works here? Do we use 5 over 18 or 18 over 5? So here, meter per second to kilometers per hour, we have to use 18 over 5. This is our, let's say, fraction. That's why the fixed number, 3 times 10 to the power 8 multiplied by 18 over 5. Actually, this is the answer. This is the last answer. 3 times 18, you have to, let's say, multiply 3 by 18. After that, the answer divided by 5 multiplied by the exponent, actually. The answer will be 1.09 times 10 to the power 9 kilometers per hour. Are we done? No, because we found velocity. But we are very, let's say, close to the answer. We have only one step. Delta x is equal to v delta t. Delta x is equal to v. We found v. Put this value instead of velocity here and multiply by delta t. It gives us, actually, the question gave it us, right? It gave it to us, actually. It says 1 hour. So instead of delta t, you have to write 1. Multiply these numbers. Any number multiplied by 1 becomes the same number. So this is 1.08 times 10 to the power 9 kilometers. This is the answer of the question. Let's move on to another question. If a metric ton is 1 times 10 to the power 3 kilogram, means 1,000 kilogram, how many 85 kilogram people can safely occupy an elevator that can hold a maximum mass of exactly 1 metric ton? The capacity, let's say, of the elevator is 1,000 kilogram or 1 metric ton, 1 ton, right? Consider that let's say that the mass of any person is 85 kilometers, right? It gave us this, let's say, question gave us this equation, this information. 85 kilogram means the mass of a person, right? So, and the capacity of the, let's say, elevator or lift is 1,000 kilogram. So how many, let's say, people can let's say, can enter the, let's say, elevator without any problem, right? So number of people is what? This is the rule, actually. You have to divide the number of the entire mass of the elevator, the capacity, let's say, capacity of the elevator, by what? You have to divide the capacity by the mass of an individual. So 1,000 divided by 85 becomes 11.76. It means 11 people. Maybe you say, why don't you use, for example, rounding rules? Why don't we, let's say, convert it to 12? Why don't we round it up to 12, actually? But the situation is a little bit different. You cannot interpret it mathematically. So in order to, let's say, to provide safety for the passengers, you have to observe the situation by, let's say, by loading the elevator less than its capacity, right? This is our goal. We want to, let's say, provide safety for the passengers. So 11 people, just remove the, let's say, estimated part, and it will be 11 people. So 11 people can, let's say, enter the elevator without any problem. And we have an explanation here. For people to be safe, the elevator has to be loaded with less than its capacity. and I explained it for you actually orally. Let's move on to another question. Question number 15, right? Question number 15. Can a set of measurements be precise but not accurate? Explain, right? Can a measure, for example, you have a reading, you have some data or information. Can we say these, for example, data are precise but not accurate? Let me give you an example. Let me give you an example about our daily life. For example, think about the age of a teacher. The age of a teacher is, maybe, let me write it here. The age of a teacher, this is about question 15, yeah? Is, let's say, the age of a teacher, for example, 35 years old, right? 35 years old. This is the age of a, let's say, I missed E here, age of a teacher. So this is the true value, 35 years old. What do you say about the age of a student? In general, maybe one student is 14 years old, maybe the other one is 15 years old, the other one's 16, and so on. So we have data here, right? Is this data, let's say, accurate, precise, or both, right? So 14 compared to the true value, right? It's away, let's say, away far from the 35. It's very far from it's too far actually from 35. What do you say about 15? 15, let's say, compared to let's say 35, it's too far actually. What do you say about 16? And let's say it's the same. It's like other students. So the age of the students are very far from the age of a teacher. That's why this data is not accurate. And you know what accuracy is? Accuracy means comparison between the data, right, and what? And the true value. That's why, let's say, we say it's not accurate. So what do you say about the, for example, precision? I want you to, let's say, check the precision of this data actually. We have a reading here. The data includes 3 readings, 14 years old, 15 years old, 16 years old. They are age of, let's say, student, 3 students. Are they close to one another? Of course, yes, they are very close to one another. That's why this data is, or this reading is precise but not accurate. Let's read the answer of question, and let me read the question again, and let's say read the answer for you. Can a set of measurements, right, be precise? Set of measurements be precise but not accurate? So yes, it can be. Yeah? Yes, it could be. It could be precise, means have a high number of significant figures. They are close to one another, but not accurate means they are not close to the true value, or let's say main value, not close to the main value. Actually, that's all for this lecture.